Welcome. We're continuing our search in the hunt for what an atom really looks like through the history of atomic theory. You can see that this is on page 146 to 152 if you'd like to read along. It's on Bohr's model. So far what we've covered is Democritus. He thought the atom was just a small ball, and then John Dalton came along with the billiard ball theory. Not much different, but he had 5 postulates to it. Then we went to J.J. Thomson. He thought it looked like a chocolate chip cookie. And now we're on Rutherford, and he has this idea of a planetary model. We're moving onward to Bohr, because there's a problem with Rutherford's idea. Rutherford thought that electrons are zipping around the outside, kind of like planets around an orbit, and there's a nucleus in the center. But the big problem with that is that electrons are negative, protons in the center are positive. Shouldn't the negative things circle around the positive things so much that they would actually implode? Because positive and negative are attracted. And they didn't actually know how to solve this part until Bohr came along. 1913. This is all kind of happening in the same time of history. Niels Bohr. Niels Bohr thought of the idea of orbits. Now, orbits are these energy levels, and it kind of makes sense because the planets live around these orbits, and it's the same idea. Electrons travel around the center, which is the nucleus, on their orbits. And we call orbits these fixed amount of energy levels, which means that the electron can't fall into the nucleus. And that's why Bohr has drawn it like this, you can see on the screen. Something to note when you're looking and drawing the picture in your notes, notice the first ring has a wide distance between it and the second ring. But then the second and the third ring is even closer. As you go out in rings, the distance between each successive ring is actually smaller. So be careful when you draw it that you show that part in yours. Something to note about these energy levels. Notice it's energy levels with an N. So each ring actually has an energy level number. This is N equals 1 because it's the first energy level or orbit. The second ring is called N for energy level equals 2, and so on and so forth. And that's how we would number each energy level or orbit. Now, these energy levels was a very distinct idea. It was why the electrons don't fall into the nucleus. Kind of like a ladder. When you step on a rung of a ladder, you don't fall all the way down because you have a place where you step on and you can hold yourself there. You can't step in between the two rungs of the ladder, just like an electron can't live in between the two rings. It has to live on an orbit. Now the question is, how did Bohr come up with this idea? A little background, I'm sure you've seen this before. We've got sunlight or any kind of light, and it goes through a prism and it creates an entire rainbow. The prism is taking all the colors of the white light and making it into a rainbow. Well, in the same idea, Bohr took things like different gases such as helium. If we take helium, a container of helium, and we run electricity through it, it'll actually energize the atoms, produce light, and the light he sent through a prism and he didn't see a rainbow. So in this case, light didn't make a rainbow. It made very specific lines of color from the rainbow, but it didn't include the whole rainbow. That was really something intriguing to him. And that was his experiment, is looking at atomic emission spectrum. That's when you're passing light through the prism from an excited atom in order to create these colors of light. Never the whole rainbow, just specific colors of light. So that was his experiment. He saw that every element actually had a different kind of spectra. Kind of like all of us have different fingerprints to show who we are, different elements have different fingerprints, or spectra in this case. And that's how we can know what element we have. And this actually also makes you think, well, if every atom has different spectra, that means every atom must be slightly different. If they're the same atom exactly, then they should have the same colors, but they don't. And that's how Bohr decided that there had to be orbits. I'll talk about that more. And every orbit or every atom has different kinds of orbits to it. So let's get into how did he see different colors? I'm going to tell you about a little story about an electron. This electron right here. He's having a great day. He's sitting in his home base, his home ring where he likes it. This home ring has a name called ground state. This electron is in his ground state. Everything's perfect and happy. And then he's going to take that atom, and it's a gas form, and he's sending electricity through it like the spectra. So suddenly all the electrons get excited. This electron has now electricity added to it, and so he's gaining all this energy and he's excited, and so he's going to jump to an outer ring. And now he lives in an outer ring. This is called his excited state. Step 1. Electrons are in the ground state. They absorb energy and move to an excited state, an outer ring. But you can't stay there very long. You always like to go back to your home, even on vacation. It's exciting out there, but you still always want to come back home, and that's what's happening for this electron. So the electron will then lose his energy, he will release his energy and move back to his home base. That's step 2. This releasing of energy is actually seen as colored light. So there's really 3 steps to it. Step 1, get excited, move outward. Step 2, release your energy, move inward. Step 3, that moving inward of releasing of energy will produce colored light. Now we saw different colors because actually different jumps. Let me tell you about a different electron. Here's an electron, he lives right here. And he's going to gain energy and move all the way out. Now he's in his excited state. Well, clearly he wants to go back to his home base, his ground state. He could do it in one big jump. That might be one color. Or he could do it in 2 jumps. One color, and 2, another color. So we can see different colors depending on what kinds of jumps you would do. I'll show you a video of this. You can see in this shot the center red dot is the nucleus and the electron is traveling around. So let's relook at the electron. We'll give it a different energy. Here's the electron. He's having a great day. In comes electricity, which excites him and he moves outward, and then he falls back inward finally to his home base in 2 steps and produces colored light. Send more energy. Now we got a lot of electricity. He gets way shot out. He'll fall back inward and produce a different colored light. You can see in the simulation we've got lots of different colors depending on what kind of jump they've got going on. That time he took a couple steps to get in. Oop, here's my screen. Okay. All right, so all in all, electrons can move in and out of the rings, and when they fall back inward, they produce different colored light. And since Bohr saw that there's only certain colors given off, therefore electrons can only live in certain rings. If you saw the entire rainbow, that would suggest that you can live anywhere and jump anywhere, but we know that it can't. That's why we see certain colors. He also knew that if there's different atoms and they have different spectra, that must mean the rings are a little bit different in each atom, and they certainly are. And that's how he came up with his idea of the orbits. And why we have the picture of the atom that we have currently in 1913 Bohr's model. Please go to the Google form. I think I have a link here on the YouTube, and I'll see you tomorrow. Bring your questions.